The second topic is urinalysis. The urinary system consists of the kidneys, ureter, bladder, and urethra. Urine is formed in the kidneys. An adult human produces 1 to 2 liters of urine every 24 hours. Urine contains predominantly water in which are mixed mostly urea and salt, especially sodium chloride. Numerous other dissolved constituents such as uric and creatinine are also found in urine. Urinalysis is a physical, chemical, and microscopic examination of urine. It involves a number of tests to detect and measure virus compounds that pass through urine. In this brief session, we will learn urinalysis from the above three aspects. Before that, let's look at how to collect urine samples. An early morning freshly voided specimen is preferred. This should be a clean cat mixed urine. A clean cat urine method is used to prevent germs from the penis or vagina from getting into urine samples. The patient is instructed to clean the area surrounding his or her urethra and then to urinate into a clean collection container. For female patients, specimen collection should avoid the menstrual period. After collected into the disposable container, the sample must be poured into the tube to do the examination of urine. Water or other chemical materials in the container will interfere the detection of cells or chemical tests in urine. The specimen should be transported to a laboratory from the day and examined within 2 hours. Now, let's look at the first part, physical urinalysis. We should observe the color, clarity, then smell its odor if necessary. We also should measure its volume. For example, the 24-hour urine sample. The odor of urine is given little importance in clinical diagnosis, but if an unusual odor is recognized during analysis, it also should be reported. Foul smelling odors may be associated with urinary tract infection and floating odors with diabetes mellitus when challenges are present. When freshly voided, normal urine should be clear and yellow to amber in color, like this. In highly concentrated urine, such as in early morning, the color may be more vivid. Urine contaminated with seminal fluid or vaginal secretions and mucus may be cloudy. Some conditions may be associated with abnormally colored urine. When it is homoglobin urea, the urine color is red. The color is black if it contains melanin. Similarly, bile pigments correspond to green urine. Nuclear urea corresponds to white urine. Porphyria corresponds to red pump urine. Turbid urine is commonly associated with abnormal conditions, especially hematuria, lambdacyuria, and bacteriuria. We touch on hematuria. So, what is hematuria? It is defined as increased numbers of red blood cells in the urine, and is an important indicator of disease involving the genitourinary tract. The picture displays gross hematuria. We can find because the color is red-brown. Increased numbers of erythrocytes may come from a variety of sources, including the kidneys, ureters, bladder, urethra, horse gland, ureter, and vagina. There are many causes of hematuria. Bladder and kidney tumors, inflammatory to the kidneys, glomerulonephritis, pyelonephritis, renal calculi, bleeding disorders related to alcohol use. The second part is chemical urinalysis. Chemical urinalysis includes tests of pH, specific gravity, merchant, chemical bodies, glucose, bilirubin, urinalysis, nitrite, alkali blood, and lactose. The examination for a special strip is used to test for substances in the urine sample. The strip has tons of chemicals that in color when they come in contact with substances of interest. Each pump contains chemicals that react with a substance in the urine, producing a color change in the pump. The color change is then compared with the various known standards. The reaction may be quantitative and quantified. Each pump in the strip represents a different material in the urine. The reference of pH is 5 to 7. pH level indicates the amount of acid in urine. pH is a measure of the hydrogen ion content of the urine. In metabolic acidosis, such as occurring in diabetes, the urine is acid. In metabolic alkalosis, the urine is alkaline. Temperature of the urine pH is important in the treatment of certain diseases, such as renal stone formation and bacterial infections of the urinary tract. Renal calculi may be formed from soluble inorganic ions, and by concentrating pH, The formation may be slow or permitted. Uric acid zones tend to be best in acid urine, and calcium carbonate zones in alkaline urine. Niacinamide zones in gases and gases in the urethra. Hydrogen nitrite provides an effective and rapid method for screening for the presence of bacterial infection. It is based on the principle that most bacteria found in the urine have the ability to reduce urine nitrate to nitrite. Additionally, urinary tract infection may demonstrate non-clinical symptoms. In these asymptomatic individuals, urine examination is of prime importance in diagnosis and in the prevention of long-term complications. A negative result when a patient is suspected of having an infection of the urinary tract should be verified by urine culture or microscopy of the sediment. Like bacteria or pyorrhea is a valuable indicator of the presence of urinary tract inflammation. The lactide esterase test is based on the release of the enzyme lactide esterase from neutrophils. Neutrophils are always associated with bacterial infections and are just found in divided numbers under these conditions. Pyelonephritis, systemic urethritis, renal pipeline, interstitial nephritis, and glomerulonephritis. These diseases all give rise to lactide. Specific gravity. The specific gravity of urine is a useful indicator of the ability of the urinal tubules to suction or dilute the urine. If the specific gravity is fixed near 1.01, it means the kidneys lost the constricting and diluting abilities in severe end-stage renal disease. Glucose. Glucose is released by the glomerulus and amounts entirely reabsorbed by the renal tubule. So, under normal circumstances, little is found in the urine. Glucosuria is defined as the presence of detectable glucose in the urine. Diabetes mellitus is frequently diagnosed and monitored by the detection of glucose in the urine. Elevated blood levels of glucose lead to similarly elevated levels in the glomerular filtrate, which then exceeds the renal threshold for glucose, and glucosuria results. Ketonuria, the presence of ketone bodies in the urine, occurs in conditions in which there is incomplete metabolism of fat. Ketone bodies consist of acetone, acetoacetic acid, and beta-hydroxybutyric acid. Generally, the second one is the predominant substance that we test. Diabetes is the most common disease in which ketosis and acidosis are found. In body control diabetes, the supply of carbohydrates is ineffectually utilized, and fat is frequently broken down as an energy source, with the product of fat metabolism appearing in the blood and urine, which result in ketosis and ketonuria respectively. Bilirubin. Bilirubin is formed from the breakdown of alpha-ethene homoglobin. Unconjugated bilirubin is water insoluble and cannot be excreted by the kidneys. Conjugated bilirubin, which can easily transport across the glomerular basement membrane, is excreted in the urine. Bilirubinuria. The presence of bilirubin in the urine is an important indicator of liver dysfunction and of intrinsic or extrinsic biliary obstruction. Bilirubinuria may be diagnosed before clinical changes appear. Bilirubinogen. Bilirubinogen is also a product of hemoglobin metabolism and is formed with the degradation of bilirubin in bacteria in the intestine. Approximately one half of the bilirubinogen is excreted in the feces, and the other half is reabsorbed into the circulation from the intestines. This reabsorbed bilirubinogen is then filtered by the kidneys and appears in the urine in increased amounts. Determination of the exact bilirubinogen in urine in a dialysis patient may be of primary importance in distinguishing between biliary tract obstruction and hepatic or hemolytic disease. If upper or common bile duct is obstructed, bilirubin does not reach the intestines, and bilirubinogen is not produced, and therefore it is not found in the urine. Conversely, in the same condition, bilirubin is greatly elevated in both serum and urine, and the bilirubin test will show a positive result. The last test of chemical urinalysis is protein test. The predominant protein present in the urine is albumin, which is filtered by the glomerulus and is not reabsorbed by the tubule. Albumin accounts for less than 30 mg per day in normal urine. The other main source of urinary protein is secreted by tubules. including T-independent hotspot, milk proportion, IgA, transferrin, beta-2 microglobulin, etc. Proteinuria, defined as increased protein in urine, is a frequent finding in intestinal disease of the kidneys and urinary tract. Proteinuria, often associated with urine sediment abnormalities, frequently serves as a basis for diagnosis of intestinal renal disease. Proteinuria is divided into three levels: mild, moderate, and severe. Most patients with intestinal renal disease present with moderate proteinuria. Patients with the nephrotic syndrome commonly excrete more than 4 grams of the protein in the urine. Here are 4 types of proteinuria: glomerular proteinuria, tubular proteinuria, negative proteinuria, and overflow proteinuria. So we can use this picture to describe the formation of overflow proteinuria. Abdomen and small molecular weight proteins flow with blood to glomerulus. Small molecular weight proteins can easily pass through glomerular barrier. If it exceeds renal tubular reabsorption, it will be found in the urine. The third part is microscopic urinalysis. A microscopic evaluation of the urinary sediment often produces valuable information that provides the clinician with a more specific diagnosis or an assessment of therapy. Most frequently, abnormal sediment is defined by an increase in numbers of cells or casts present. In urine sediment obtained from a disease-free person, small quantities of erythrocytes may be present. This is the reference. Medical causes of hematuria include glomerulonephritis, pyelonephritis, cystitis, and neoplasms of the kidney and urinary tract. In bladder or renal cell carcinoma, microscopic hematuria is often an early and important finding that is manifested during a routine laboratory workup in an asymptomatic patient. Diamorphic erythrocytes have been described when the hematuria originates in the kidney. This deformed RBC becomes an important indicator of intraglomerular hemorrhage. Diamorphic RBCs have been out of shape and into posterior angles but are not disrupted. Why are they diamorphic? The posterior connections of the red cells are thought to be caused by clotting through a damaged CPM. WBCs are frequently found in the normal urine sediment, but are few and do not exceed 5 per 5 power field. WBC appear in increased numbers in the urine when an inflammatory process affects the urinary tract. Urea is a common finding in cystitis, urethritis, and pyelonephritis. The white cells are predominantly PMN, but studies have shown that lymphocyte monocytes may also be present. Normal urine contains three main kinds of epithelial cells: renal tubular, peritoneal, and squamous. Epithelial cells may occur in the urine sediment in increased numbers in pathologic conditions. For practical purpose, only increased numbers of RTE cells is of clinical significance. Renal tubular epithelial cells are increased in the urine when there has been damage to the renal tubules, and the cells are stuffed. This disease is a common cause of RTE cells. This picture shows 4 kinds of epithelial cells. This is squamous cell. It's the biggest inside among them, with a small nucleus inside it. Colored epithelial cells similar IQ. Urine tests. Urine tests are defined as clinical microscopic structures that form in the distal nephron and occur in the urine in both health and disease. The cylinders are composed primarily of a kidney-specific protein that is produced only in the distal tubule and collecting tract of the nephron. In normal state, only hyaline tests appear in urinary sediment. Any additional test forms must be considered abnormal and are most often associated with generalized metabolic or intestinal renal disease. The picture displays hyaline tests. They are cylindrical and clear. And this picture displays granular tests. They are cylindrical but with much granular enzyme. They are RBC tests with many RBC enzymes. WBC tests have many white blood cells enzymes. Crystals. Crystal can cause kidney stones, but amorphous crystal animals, such as amorphous urine crystal, amorphous phosphate crystal. The most common constituent of kidney stone is calcium oxalate crystal. Common crystals seen even in healthy individuals are charcoal phosphate crystals and amorphous phosphate. They've also been seen in renal stones. Amorphous phosphate crystal can be found in normal people. It often appears in alkaline urine. Amorphous uric crystal also can be found in normal people. It often appears in acid urine. This is uric acid crystal. It has many shapes in urine. And this is calcium oxalate crystal. It's the most common crystal. Other crystals will be seen in the laboratory test. When we find yeast in urine samples with fungal urinary tract infection. Now, let's make a review for urine microscopic examination. The left column are the constituents we found under microscope, including fat, cells, crystal, and yeast. The right column are the corresponding disease. The above is all the content of this lesson. If you have any questions, send me an email. Okay, class is over.